Now we have to differentiate between the vectors quantities and the scalar quantities. The scalar quantities has two main values, the magnitude and the units. For example, if we have the mass equal 5 kilogram, the magnitude is 5 and the unit is kilogram. It, it's independent to the direction. But if I talk about the vector quantities, for example, if we have a velocity equal 5 I m per second, so we have the magnitude, we have uh, the direction, and we have the units. So to have the identity of any vector, we have to precise the magnitude, the units, and the direction. For example, we have many examples of the scalar quantities. We have the temperature, we have the volume, we have the density. All these values are independent of the direction. You need the magnitude and the units to identify these quantities. But the vector like a, the acceleration, the position vector are vectors quantities. I give you an example about the vector and the scalar quantity. I have a point A and the point B. If I go from A to B like this in this path, so this path is the distance, the real distance from A to B. But so the distance is a scalar quantity. But the displacement, we will talk about the displacement later. The displacement is a vector, must join the initial point to the final point. It doesn't depend to the path of the distance. So the displacement is simply a vector join the initial point to the final point. This is the difference between the vector and scalar quantity. Vector notation. A vector notation must be, for example, if we have a vector A, the notation is A with a arrow. في عندك على طول انت اللي تحدد اذا هيدا فيكتور بتحط ال A وما تنسى الفلاش فوقها. The magnitude of A must be like this. You can write A as a magnitude or A like this. These are the magnitude of the vector A, and this is the vector A. The same if we have the velocity v, example v equal 5I plus 2j, this is the vector quantity. The magnitude equal 5 square plus 2 square. So you can write like this or like this. It's the scalar quantity. The equality of two vectors. How can I say A equal to B? A equal to B when you have two conditions. First of all, when the magnitude of A equal the magnitude of B, 2, 1, 2, when the angle of A equal the angle of B. Don't forget, the angle is between the vector and x-axis. So, if I say this is A and this is B, at A we have the tail and the tip of the vector. I can do x-axis and y-axis here, x-axis, y-axis. The angle theta A is between the x-axis and A. This is the angle theta A. The same for B. For the B, we have the tail and the tip. On the tail, we can do x-axis and y-axis. The angle theta is between the vector and the x-axis, so it's theta B. If the magnitude of A equal to the magnitude of B, this is the magnitude equal RA, the length of the vector. And this is the magnitude of B equal RB. You can say A and B, or RA and RB. If RA equal RB and the angle R equals, we can say A equal to B. Adding vectors. How can we add two or many vectors together? Okay, I take an example. We have two methods to add two vectors. The first one called tip to tail. What does it mean, tip to tail? I have a vector A, for example, I have a vector A and a vector B. To add A and B, I can move this one to A. Like that. I have to put the tip. I said this is the tip. Excuse me. This is the tail, tip, tail, tip. I have to put tip to tail like this. Tail, tip, tail, tip. Here we have tip, tail. So it's a tip to tail like this. Tip to tail. So I put A and B like this and I join the tail to tip. It's A plus B. Even if you have many vectors like this, A, B, C, D, I put tail, tip, tail, tip, tail, tip, tail, tip, and I join at the end the tail of the first one to the tip of the last one. This is the addition of all these vectors. This is the first method. The second method, it's tail to tail. Tail to tail. For example, I have A, I have B, I move B to A, tail to tail. It means I have to put the tail to tail, like this. The tail of A with the tail of B. When I put tail to tail, I can do this form to calculate the addition of A plus B. I can add A plus B by forming the parallelogram. These two methods, I can give you an example. If I have y, I have x, y, and x. Here we have, for example, A. Here we have B. This is A. This is B. We have here tail to tail. To add A to B, we have to calculate the diagonal. This is A plus B. How can I do the subtracting vectors? For example, if I take A and B, A and B, we have only one method to subtract two vectors. For example, I put tail to tail. If I join this vector with this one, it will be A minus B because it's directed to A. It means the final minus the initial, A minus B. But if I join A to B in this direction, it will be the final minus initial. It's very important. How can we add geometrically two vectors?